Welcome back to Engineering Acoustics. Hi, this is Professor Ryan Harne. In this video, we'll learn about the fundamentals of acoustic transduction, as well as the basics of audiological management.
So let's get started. Acoustic transduction is the conversion of acoustic energy into energy in another domain. For instance, microphones. These are acoustic sensors, and they convert pressure waves to the vibrations of the sensing material, such as the polarized diaphragm, and then that in turn creates electrical signals, which in proportion to its sensitivity tells us about the measured acoustic pressure. Vice versa, acoustic loudspeakers convert the electrical signals to the vibrations, which radiates acoustic waves. Sensing and radiation are opposites. Speakers can serve as sensors, and sensors can actually serve as speakers. For instance, we could measure a recorded sound from a loudspeaker if waves are incident on the loudspeaker surface. It doesn't work very well, though, and that's because in practice, loudspeakers and microphones are optimized for their roles. Let's learn more about these acoustic transducers, especially loudspeakers. If a friend told you that they were developing a new loudspeaker at home and they were excited to share the design with you, and they opened up a notebook and showed you these schematics, what would you say? Would you know that the speaker on the left is a closed back speaker and the speaker on the right is a bass reflex speaker with a port? Loudspeaker design nowadays is highly electrical. It's due to the fact that there are electrical mathematical analogs for mechanics and mechanical design, as well as for acoustics, so speaker development is as much of an electrical problem as it is a mechanical design problem as it is an acoustics problem. The fundamental principle, though, and especially since the design is handled in an electrical domain, the fundamental principle is to match impedances. And this helps to optimize energy transfer from the amplified electrical signal from the amplifier, for instance, through the transducers, all the while modifying the aesthetics and design of the cabinet, which tailors the circuit design so that we can enhance aesthetics. This is a daunting task, though. Depending on our interests, there are several resources available to guide us through loudspeaker design. We will not cover this in greater detail in this course due to the fact that it could be a course unto itself, but I encourage you to check out these resources. For a rigorous and theoretical approach, I would recommend Baranek and Mello, their textbook from 2012. For a down-to-earth yet still theoretical approach, I would encourage you to check out Murphy's Introduction to Loudspeaker Design. But if you want to get into your workshop and start building a speaker today, I encourage you to check out Parts Express. At the bottom of their webpage on the homepage, they have a resources tab for technical help. Changing subjects, yet still looking at an outlet of acoustic transduction, audiological management refers to the clinically recommended efforts for patients to manage their hearing impairment. Because hair cells in the cochlea do not regenerate, there's no means for therapies to regenerate cochlear nerve activity in the event of hearing loss, although this is an intense and active area of research. So, in the meantime, audiological management begins with hearing aids and progresses to other modes of hearing restoration, such as cochlear implants, based on the severity of hearing loss. Hearing aids are the first resort to recover hearing. They act simply by amplifying signals received at the oval window to compensate for the perception deficit at the hair cells. Most hearing aids consist of a battery, microphone, signal processor, and an in-ear speaker. The battery and processing might occur outside of the ear, such as the photo on the top, or the processing and the battery might be contained in a fully in-ear unit, like the unit on the bottom. The processing is customized to the wearer's hearing loss, and that's conducted in a medical office. And this ensures that the compensation is proportional to the need. A doctor of audiology, their degree is in AUD, determines if the hearing loss in one or both ears warrants the management of a hearing aid. The hearing aids fit into the outer ear to take advantage of the pinna filtering. So for the hearing aid that is entirely encompassed in the ear canal, this helps to minimize occlusion effect, which is the phenomenon of booming sounds when we speak with our ears covered. There's a possibility that the hearing aids may actually accelerate hearing loss. And this is due to the fact that they're amplifying sounds to an already weakened set of hair cells. A cochlear implant is then the resort for people with profound hearing impairment, and especially for children. A cochlear implant directly stimulates the part of the auditory nerve along the basilar membrane that's impaired. We see it here. An electrode is woven around the wrap of the cochlea, and it is driven at certain locations in proportion to the sound that's received at outside transducers. Part of the cochlear implant is embedded, and part is external. An electrode sends the signals along the basilar membrane to reconstruct the hair cell stimulation. The success of cochlear implants has been remarkable, yet it is most successful when the implants are postlingual. In other words, when deafness occurs after language has developed in the patient. It's also most successful when the onset of deafness is most recent. In other words, the cochlear implant is applied shortly after deafness occurs. And it is most successful when the implantation occurs soonest for the patient, for instance, for children who are extremely young. Let's summarize what we've learned. Acoustic transducers convert acoustic energy into something else, very often electrical energy or electromechanical energy, and they use electromechanical elements to do so. There are many ways of managing hearing impairment depending on the severity of the hearing loss, and the predominant approaches to date address hearing loss by enhancing the activation along the basilar membrane. But there's a lot of reason to be hopeful. Many researchers are giving attention to developing drugs that stimulate hair cell growth, and this could one day genuinely restore people's hearing.
That's it for this video. So far, we've learned about sound levels and how they're calculated. In the next video, we'll learn about how engineers often evaluate sound levels in terms of frequency bands.